Hey guys, in this video I'll be doing this question as follows. While playing a game of billiards, your 0.17 kilogram cue ball traveling at 1.9 meters per second glances off a stationary 0.16 kilogram 8 ball so that the 8 ball moves off at 1.3 meters per second at an angle of 32 degrees clockwise from the cue ball's original path. The question asks, what is the final velocity of the cue ball? So it's asking us a cue ball is traveling at a velocity of, let's say, vc, and is heading towards an 8 ball. And once it hits and collides with the 8 ball, the cue ball is gonna go somewhere here. We can call this vc prime. And the 8 ball, we know, moves off at an angle of 32 degrees clockwise from the cue ball's original path. The cue ball's original path is here, so the 8 ball is going to go somewhere here, and this angle would be 32 degrees. When we're dealing with collisions and we're doing AP Physics 1, the first thing that we want to think of is momentum, momentum, momentum. And this fits perfectly because we have the mass, we have the velocities, and we're also trying to find the final velocity. So in this case, we are going to use the energy conservation law. Since there's no friction, we can do this. So the total energy or momentum of initial is equal to the total momentum of the system after the collision. The initial momentum is composed of only the cue ball because the 8 ball's velocity is 0. So there is no momentum at the 8 ball in the first place. So the momentum of C, we can just directly write this down, PC equals the momentum finally, which is both the momentum of the C after the collision and the momentum of the 8 ball after the collision. So we could say PC prime plus P8 prime. And we're solving for the final velocity of the cue ball. So that means that we need to solve for PC prime. Now PC prime would be equal to PC initial minus the momentum of the 8 ball at the end. In order to do this, we see that we have the initial momentum of the cue ball. It's just mass times velocity. And we have the final momentum of the 8 ball. And we need to find the final momentum of the cue ball. In order to do this, we can split the system up, the velocity vector up into two components and solve for each of them using sine and theta with this angle. Here's what I mean. Let's say we have the velocity of the cue ball after the collision. If we can find the y component, let's call this yx on this chart. If we can find the y component and we can find the x component, we can use the Pythagorean theorem to find out our total vector. So we're going to do exactly that. Let's start with the, let's say, y component. So the y component, we see that PC prime y equals to PC y plus P8 final y minus P8 final y. The P initial, the initial, sorry, the final y component of the cue ball, that's what we're trying to find. So p c prime y equals the initial y component of the cue ball. As we know, if this is x and this is y, then the c component is not going anywhere in the y component. So this would be just 0 times mass, which is just 0 minus uh, p8y. And the p8y, if we see this as a triangle, then it will be negative the momentum of the A ball, A prime. So the final momentum of the 8 ball times sine theta, opposite over hypotenuse. So we're left with this side. So P final of the y component would just be M8 V8, sorry, M8 V8 prime plus times M8 V8 prime sine theta. And PC prime y would be equal to the mass of the 8 ball, which is uh, 0.16 times the velocity, final velocity, is 1.3 times sine of theta, sine of 32 degrees. PC prime y equals, when you plug that in your calculator, you'll get around 0.11 kilogram per meter second. Okay, now on to the x component. I'll do it, let's see right here. Now, the x component is a bit more interesting because it actually takes into consideration about every single component, unlike the y component, where this pcy was 0. So the x component says that p c prime of x equals pc of x minus p8 prime of x. Pc of x minus p8 x prime. Okay. Now, the initial, we need to solve for this, and the initial x component of the momentum of the cue ball would be equal to vc times mc. Oh, in case you don't know, momentum equals mass times uh, velocity minus. Now, this would be considered the same thing as this, but in cosine, because cosine is adjacent, and we are solving for this now. So, minus negative m8 v8 times cos theta. And let's move it here. That's going to give you vc, okay, times mc plus m8 v8 prime cos theta. And vc times mc, the velocity of the cue ball times the mass, is 1.9 times 0.17, 1.9 times 0.17 plus mass of the 8 ball is 0.16 times final velocity would be 1.3 cos of 32 degrees. And when you plug it in, you'll get around 0.0 0.147 kilograms per meter second. Oops. 1 point, sorry, 0.147 kilograms per meter second. And now, like I said, we can directly just use a Pythagorean theorem to calculate this. So the final momentum would be equal to root 0.11 squared plus 0.147 squared. And when you plug that in the calculator, you will get around 0.18. And let's see how many significant figures. Yeah, okay. 0.18 kg per meter per second. And now 0.18 equals mass times velocity. 0.18 equals, we know the mass. The mass is 0.17 times velocity. So V would be equal to 0.18 divided by 0.17, and you'll get around 1.1 meters per second. Now it also asks you the direction of the cue ball. Well, the direction would just be, if we know this, and we know this direction is going all the way here, and this direction is going all the way up, then we can say that we can calculate for this angle, because tan of theta would be equal to opposite Vy over Vx. And we know these two, so we can just calculate for theta. Or if you want the other way around with cotan. So tan of theta equals opposite over adjacent, which is Vy over Vx. Theta would be equal to inverse tan Vx. Theta would be equal to, if you plug this in with Vy equal to 0.1102 over 0.1466, you'll get about 36.9 degrees. And these two would be your final answer. Sorry, this is not very neat. So, yeah, this is a very interesting question. Just remember that whenever you see this type of question, you got to think about momentum, the conservation of momentum, because that is really important. And if there's an angle, you got to think about cos for usually x components and sine for y components. And yeah, that's it. And don't forget to convert your final momentum into velocity, because that's what the question asks. So, yeah, thank you for listening, and I hope you enjoyed.